Right, retrieval roulette, pause, get these answered in your books, thank you. Okay, so here's your answers. So again, pause, mark and correct these for me. And now we can start on to today's work. So if you remember, last lesson we spent a bit of time talking about Newton's first law and Newton's second law. So quick recap. Newton's first law, if the forces are balanced on an object, so there's no resultant force, then the object is just going to keep on doing whatever it is doing. So it will either be sitting stationary or it'll be travelling at a constant velocity. Now, Newton's second law, if there is a resultant force on an object, it's going to make it accelerate. Now, I'll try and say that properly. So the acceleration is inversely proportional to an object's mass, directly proportional to the force applied to it, and acts in the direction of the unbalanced or of the resultant force. And mathematically, F equals ma. Okay, so remember last day I said, like, I don't remember that one off by heart, but I just think through F equals ma and what it means. But that is because I am a bit more of a malsy person than a wordy person. You might prefer just to learn off the words. But either way, whatever works, as long as you know what it means and that you can state it. So we're going to be looking today at applying mostly Newton's second law, which if you remember is F equals ma. But there's a couple of wee bits here where Newton's first law sneakily comes into the questions. But before we do that, we need to make sure that we know how to calculate a resultant force. Now, I sort of did this a little bit last lesson. I would have, like, whenever we looked at the forces that were acting on something, I said, like, oh, well, that's going to be a resultant force of 4 to the right or whatever it was. Okay, it's just that. So let's have a wee look here. When several forces act on an object, we can add them together to find out what's going to happen. So the combined effect of all the forces on an object is called the resultant force. So the combined effect of all the forces, resultant force. For GCSE, you're only ever going to be asked to deal with forces which are all in a straight line. If you go on to do A-level physics, then we've got forces acting in all directions. It's some of my favourite stuff to do, right? So if I push a car with a force of 500 newtons and somebody else pushes the car the other way with a force of 400, what's the resultant force? So here's my car. Let's say I'm pushing. Now, you might be like, well, that doesn't look like a pushing force, but I could have drawn it going in this way at 500. It would have been fine, but I just prefer to always draw the forces coming from the object. So here's me pushing with 500 newtons this way. Here's Mrs. Turner, she's weak. She's only pushing with 400 newtons that way. So we've been asked to find what is the resultant force on the car. So the resultant is going to be the 500, take away the 400. So we've got 100 newtons to the right. Now, whenever I did that, I didn't really state it anywhere, but I have really taken to the right as being positive and to the left as being negative. Could have done it the other way around. I would have got minus 100 to the left, and then I would have had to equate that to 100 to the right. Okay, I'll stop rambling because I think you probably get that. Now, this example 2 is one of those wee sneaky ones. So we've got a bunch of extra stuff to write in here. Okay, so let's look at it. A block of mass 2 kilograms is pushed along a table with a constant velocity by a force of 5 newtons. When the push is increased to 9 newtons, calculate the resultant force and then the acceleration. Now, I've said here, be careful. Questions like this sneakily involve both the first and the second law, and they always catch people out. So let's look at it again. A block of mass 2 kilograms is pushed along a table with a constant velocity. Constant velocity means the forces have to be balanced, right? So let's say this here, I've written first as in first law. Forces are balanced. The forces have to be balanced if something's going at a constant velocity. Now it tells us that that happens with the force of 5 newtons, but then, this is our second scenario, that force is then increased to 9 newtons, and then we have to calculate all these things. So let's go. When it's pushed to 9 newtons, we have to, so let me say, I'm going to go first here. The constant velocity means the forces are balanced. Now, if we're, what is this? Just a block. If we're pushing a block along a table, there's going to be friction. So this told us that whenever the forward force was 5 newtons, this thing went at a constant velocity. Well, if we look there, if it's going at a constant velocity, the forces have to be balanced. That's not balanced, that's a resultant force of 5. So that means that the friction force has to also be 5 newtons for these to be balanced, for this to be going at a constant velocity. Right, I'm going to write in a wee extra note about that. So use the fact that they've told us when the forward force is 5, then it's going at a constant velocity. The forces have to be balanced, so that must mean the friction force is 5 newtons. Okay. When the push is increased, so second, when the push is increased to 9 newtons, here's our scenario. So this 5 is now 9, but we still have the friction force of 5 newtons acting back the way. So that is where that has come from, and this is the bit that catches everyone out, and I can understand why. Hopefully I've made it obvious to you. If not, remember, you can ask. So the resultant force is going to be 9 take away 5, which is 4 newtons to the right. Okay, so I want you to add in this wee extra note as well. This is the trick that gets us through these questions. So we use when the forces are balanced to figure out the friction forces, which are always there. Unless the question tells you otherwise, they're always there. Okay, so that's the first part. I'm going to go back to this question again. So a block of mass 2 kilograms is pushed along the table with a constant velocity by a force of 5. When the push is increased to 9 newtons, we have to calculate the resultant force, and then we have to calculate the acceleration. So we're going to use Newton's second law. If you remember the equation for Newton's second law, F equals ma. Now, add in this note. This is another really common mistake. A whole lot of people will just look at that question and immediately put in 9 there because that's the force that's being applied. But the force in Newton's second law, if you look back at it in your notes, it's the resultant force or the unbalanced force. So the acceleration is inversely proportional to the mass, directly proportional to the unbalanced force, or we could say directly proportional to the resultant force. It's not directly proportional to one of the forces that's acting on it, it's directly proportional to the overall effect of the forces. So let's add that in there. So the F in F equals ma is the resultant force. Now, no matter how many times I say this, I can guarantee some of you are going to make that mistake. Prove me wrong, right? I'm very happy to be proven wrong. Okay, let's go back to the question. So we had to calculate the acceleration. So we're if something's accelerating and we have to, and you have to relate the acceleration and the force, it's going to be F equals ma. So our resultant force is 4 newtons. The mass is 2, and the acceleration is what we're being asked to find. So if we divide both sides of that equation by 2, we get 2. So the acceleration is 2, and the units of that meters per second squared. So I need you to do the questions on page 183, so we've skipped out 182 there, and we're going to leave them out for now. We might go back to them, and I'm just going to talk you through each of these just to get you started. So what force is needed to give a mass of 10 kilograms and acceleration of 2? That's just going to be F equals ma. Straightforward, F equals ma. Same here, we've been given the mass and the resultant force, and we have to calculate the acceleration. Straightforward, F equals ma. 3. Again, we have the acceleration and the force, we have to get the mass. Straightforward, F equals ma. However, we bit of rearranging involved. We're experts at that. 4. This one here is a little bit more awkward. So we've been given the mass. In fact, I'll start to make my list here. We have the mass is 800. It accelerates from 5 to 25. So its starting velocity u is 5. Final velocity v is 25. And that took 10 seconds. Part A is asking us for the acceleration. Hopefully, making that list, you can see that you're going to calculate the acceleration using a equals v minus u over t, or v equals u plus at. And then once you've got the acceleration and the mass, you can calculate the force for part B. Right, I've been joined by one very needy dog, but let's look at question 5. A car driver of mass 60 kilograms is in a crash. He decelerates from that to rest in 2 seconds. Calculate his deceleration. So that's very like question 4. If I make my list of information, you can see there that I've got a starting velocity, a final velocity, and the time that it took. So that's actually going to give you a negative acceleration, but the question asks for deceleration, so just change that into a positive. Then once you've got that, you can use that in F equals ma. Now, whenever you're doing that, you don't have to worry about putting your acceleration in as negative. Just use the magnitude of it, the size of it, okay? Right, let's look at question 6. So a supermarket trolley, has a mass of 20 kilograms. When pushed by a force of 15 newtons, it accelerates at 0.5 meters per second squared. Calculate the resultant force of the trolley. So I'm going to make my list of information here. Now I've been a bit sneaky there. So it told us its mass 20. It was pushed by a force of 15 newtons, which you can see in this wee diagram here, right? And it accelerates at 0.5. We are being asked to calculate the resultant force. So we have a mass and an acceleration, I can nearly speak. So we're just going to use F equals ma for that, okay? And that's going to give us the resultant force on the trolley. Then part B asks for the friction force. So to get that, we're going to use the value of the resultant force and the value of this forward force. Now, I'm going to draw a wee diagram. We're going to have our 15 newtons acting that way. And we're going to have our friction, I'll call it FR, right, acting that way. These two have to combine to give us this resultant force. That's my hint for that one. Okay, and then 7, a car has a mass of 100 kilograms, 1,000, travelling at 20 meters per second, so U is 20. The brakes then exert a steady force of 5,000 newtons. So here's our car, brakes, say it's going that way, the brakes are going to apply 5,000 newtons to the left. Hold on. So this here, in this case, is the only force acting, the 5,000 newtons to the left. So for part A, to get the deceleration, you're just going to use F equals ma. The force is 5,000 and the mass is 1,000. Now, part B then asks how long does it take to stop the car. So it's asking for the time. If it's stopping, the final velocity is 0. We have the initial velocity as 20. I'll list it down here with it. So U is 20. We will have just figured out the acceleration in part A. So we'll be able to use A equals V minus U over T to figure out how long that took. You might actually find, using V equals U plus AT version of that easier to solve for T, but you can use A equals V minus U over T, either one. Okay, that is me. So get on with those questions and then let me see them. Okay, bye.